Now let's turn our attention to the probability of making a type 1 or type 2 error. So remember, we never know whether the conclusion of a hypothesis test is correct or not. However, we can assign probabilities of making type 1 or type 2 errors when doing hypothesis testing. And so alpha is the probability of making a type 1 error, meaning the probability of rejecting H naught when H naught is true. And beta, it's another Greek letter. And just as an aside, alpha beta is where we get alphabet from. Beta is the probability of making a type 2 error, which remember is the probability of not rejecting H naught when H1 is true. So the probability of making a type 1 error, alpha, is chosen by the researcher before the sample data are collected. Now, the level of significance is alpha, which, remember, is the probability of making a type 1 error. The choice of level of significance depends on the consequences of making that type 1 error. So if the consequences are severe, like, you're testing a medication and you want to know about deadly side effects, then the level of significance should be very small. Say, for example, 0.01. However, if the consequences are not severe, then you can pick a higher level of significance, like 0.05 or maybe even 0.10. Why is the level of significance not always set at 0.01? Well, it's a trade-off. So when we reduce the probability for making a type 1 error, that increases the probability of making a type 2 error. So there's what we call an inverse relationship between alpha and beta. As one goes up, the other goes down. So let's talk about stating the conclusions of our hypothesis tests. Once the decision of whether or not to reject the null hypothesis is made, we have to state our final conclusion. So it's important to know that we never accept the null hypothesis. And that's because, remember, sample evidence can never prove that the null hypothesis is true. By not rejecting the null hypothesis, we're not saying that the null hypothesis is true. We're saying that the evidence indicates that the null hypothesis could be true. So how do we format the conclusion? So if we reject the null hypothesis, there is sufficient evidence to conclude, and then we state the alternative hypothesis. Okay? If we do not reject the null hypothesis, there is not sufficient evidence to conclude, and then again we state the alternative hypothesis. So reject, there is sufficient evidence. Do not reject, there is not sufficient evidence. So let's do a couple examples. The Medco pharmaceutical company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. This is the same problem we've done several times before. Suppose the sample evidence indicates the null hypothesis is rejected. State the conclusion. So we would say there is sufficient evidence to conclude and here's where we state the alternative hypothesis. So that the proportion of children, not students, who experience headache as a side effect is greater than 0.02. Okay, what about if the null hypothesis is not rejected? What is our conclusion? Well, we say there is not sufficient evidence to conclude that the proportion of children who experience headache as a side effect is greater than 0.02. That concludes our discussion about the basics of hypothesis testing. In the next section, next week, we will pick up with how to actually conduct a hypothesis test about a population proportion.